Hello and welcome to Math Lessons with Linda. Today's topic is how to find trig function values using special right triangles. If you are not familiar with the two kinds of special right triangles, you will want to get some reference material, look those over, and then come back to our video. I am going to give you the two special right triangles, and then we will use those to find our trig function values. The first special right triangle is a 45, 45, 90 right triangle, and the values that we use for the sides are 1, 1 for the legs, and square root of 2 for the hypotenuse. The other special right triangle that we have is a 30, 60, 90 degree right triangle. And the values for the sides that we use are 1, square root of 3, and 2. If you would like to verify that these values do indeed form a right triangle, you can use the Pythagorean theorem and check that out. So for trig functions, most of the time, if you're using them for the unit circle, you are going to want to have the sine, the cosine, and the tangent. And if you remember from any previous trig work, we will use what's called SOHCAHTOA to help us find these values. So what that means is that the sine, which is the S, we take the opposite over the hypotenuse sides of the triangle. The cosine, the C, we take the adjacent over the hypotenuse sides of the triangle. And for tangent, we take the opposite over the adjacent. And we will do this for both of these triangles. So we're going to start off with the sine, and we are going to do the 45 degree angle. I need to know the exact value of the sine of a 45 degree angle. So when I'm doing the sine, I'm going to choose my angle, and then I'm going to do the opposite side over the hypotenuse. So from here, opposite is 1, hypotenuse is square root of 2. So 1 over the square root of 2. Now, we don't typically leave a radical in the denominator, so if I want to rationalize that, I'll multiply the numerator and the denominator both by the square root of 2. So I get the square root of 2 over 2 is what the sine of 45 degrees would be. You can box it off. The next thing I'm going to do is the cosine of 45 degrees. So the cosine is the adjacent over the hypotenuse. So here's my 45 degree angle. Adjacent is 1. Hypotenuse is square root of 2. Because the legs of a 45, 45, 90 right triangle are the same, that's why the sine and the cosine values are also the same. So I get the square root of 2 over 2 once again. My last value would be the tangent of 45 degrees. So the tangent is the opposite over the adjacent. So from here, opposite is 1, adjacent is 1. So the tangent is 1 over 1 or just 1. So these are our three values for sine, cosine, and tangent of a 45 degree angle. And since we have two of the same angle in this triangle, we don't need to do it for both. We'd get the same values for the other 45 degree angle. So now what we want to do is shift over to our other triangle, which is the 30, 60, 90. And we are going to have to do two separate things using the 30 degree angle for all three trig functions and using the 60 degree angle for all three. So let's start off with the sine of 30. Remember that sine is opposite over hypotenuse, so the sine of 30 is 1 over 2. So the sine of 30 degrees is a half. Let's do the cosine of 30. So the cosine of 30 is going to be the adjacent, so square root of 3 over 2. So square root of 3 over 2. And the last one we have is the tangent of 30. tangent is adjacent over my opposite over my adjacent. So I've got 1 over the square root of 3. We run into the same problem here with the radical in the denominator. So we're going to multiply by square root of 3 for both. So the square root of 3 over 3, that's what my tangent of 30 degrees would be. Okay, so keep all these values in mind, because now we're going to do the same thing and we're going to use our 60-degree angle. We're going to start over at sine. So the sine of 60 degrees. So now my 60-degree angle is up here. So opposite over hypotenuse. So square root of 3 over 2. This number should look familiar because it was the same thing as the cosine of our 30-degree angle. So for the cosine of 60, cosine is the adjacent over hypotenuse. So adjacent is right here at 1 over 2. So the cosine of 60 is a half. That should also look familiar. It was the sine value for 30. And then the last one we have is the tangent of 60. So remember that tangent is opposite over adjacent. So opposite is square root of 3 over 1, which we can write just as the square root of 3. So we have found all of the sine, cosine, and tangent values for the 30-degree, the 60-degree, and the 45-degree angles. These are values that you can write directly onto your unit circle and use throughout the trig units that you may have in your class.